Excellent. All right. Welcome, everybody. So we have some, I think it's a really exciting topic and definitely very relevant these days, with the LLMs, ChatGPT, and all that kind of good stuff out there. So we've taken a very serious interest in it ourselves and tried to figure out, first of all, understand it better. What actually is an LLM? How does it work? And in some cases, and I'll point at Cory there briefly. I know that he's actually gone so far as to build his own. So we've done some of that stuff. And then also kind of starting as a thought experiment. Okay, well, are there things that we can do to leverage AI from a security perspective as well? And so maybe there's some good that can come out of this, because we hear a lot of the negative press around it, right? So that kind of got us thinking, okay, well, what are some of the positives? What are some good things we can do? I would love to be able to jump to some sort of demo of security Copilot or something like that, but at this point we don't have access to it yet. So Microsoft, if you're watching, we want access to that. That'd be really cool. So we could play with it. What I'm going to do is we have Cory and Alex here. They are both consultants at Secure Ideas, both been with us for a while, and both of them have a very keen interest in just automation in general, but also getting into AI and machine learning and that sort of thing. So I'm going to, if Cory's ready, I see your mic's still off. So you're still muted.
Just wanted to make sure there wasn't any feedback or anything.
Okay. I'm going to hand it over to you, and I'm not sure where Alex disappeared to, but
he did say that his internet was being a little spotty. So
okay, there we go.
He's back now, though.
We're back, yay! So hopefully we can get all of this to work. We were having some issues a moment ago, right before we joined, with being able to have slides and being able to switch to a demo screen. So I'm hoping that we'll get past that. It was UI issues with our with Big Marker here, but so hopefully that's fixed. So I'm going to hand it over to Cory, and he will take it from here. So,
all righty,
Cory, take it away.
All right, yeah. So I'm Cory. I'm a senior security consultant at Secure Ideas, and like Jason said, I've been doing a lot of stuff with machine learning and AI kind of on the side recently. I'm actually building a product, an AI-based product, so I'm going to shill that a little bit. But my background also includes machine learning and artificial intelligence a long time ago when I was in college at this point, it feels like. So today, we're gonna talk about artificial intelligence as a security ally, right? There's a lot of fear, upset, and disruption, FUD, around artificial intelligence technology. But in my opinion, once you start to dig into how it works, sort of demystify it a little bit, and you I think, realize the power that is here with this technology for just allowing us to do our jobs better. So yeah, we'll dive right in. With this webinar, there's a couple questions that I think I kind of want to ponder, right? What really led to the current boom of AI that we're seeing now, right? Like, it seems like just in the last few years, we always had AI stuff and machine learning, but just in the last few years, this sort of exploded, right? So why did that happen? We'll talk about the technology that kind of came about that enabled things like ChatGPT to be created and be as effective as they are. Also, what is a large language model anyhow, right? And what does GPT even mean, right? These terms get thrown around a lot, but I don't think a lot of people are defining what they mean and what they really are. And then we'll talk about, what are large language models, or LLMs for short? What are they good at? What do they really excel at? And how can we leverage that in the space of cybersecurity? Yeah, so, quickly, what does GPT mean? Well, so GPT stands for Generative Pre-trained Transformer. And that also probably doesn't clarify things very much, right? But what that means, kind of at a high level, is it's a neural network that is designed to generate content. It's pre-trained on a large set of data, and transformer stands for a type of neural network. And I'll let you in on a secret. That's the type of neural network. That's the technology that kind of is sort of responsible for this boom in AI that we're seeing. Again, things like ChatGPT, the GPT models, and those being so good at like condensing information and generating new text and things of that nature. The transformer is really the key to that. So what is a transformer, right?
Autobot or Decepticon?
Right, Autobot or Decepticon. I guess it depends on how you choose to use the AI model, right? Use it for good or use it for evil. I don't know. Yeah. But they're more than meets the eye.
Yeah. And the puns start.
And there's this gnarly diagram over here, which is taken from like the original paper that was published in like 2017 on this transformer architecture. I'm not going to pretend that I know how to explain this diagram very well, but it's cool looking, right? It looks. I like the colors and it's nicely formatted. But what a transformer is it's a type of neural network that's capable of learning context by tracking relationships in sequential data, right? So that's an important part, is the sequential data, right? So like natural language text is sequential. In English, it goes, from left to right. And that's essentially what these models do is even when you prompt them, they're incorporating that prompt and it's processing the prompt, and then it's essentially guessing what should come after the prompt, right? And it's doing that in a really, really fancy, smart way with a bunch of calculus and things like that.
Now, quick question. I know I'm interrupting your presentation. I mean, hopefully,
this is kind of the slides are short, so this is kind of meant to be discussion, a little discussion based here. And
so I've played around with ChatGPT quite a bit, and I've noticed that it seems to work better when there is like some back and forth. Some is like I say something, it responds, I respond to its response, it responds to my response, and then it seems to kind of get closer and closer to what I'm aiming for.
Yep.
Is that a result of this sort of generative loop, like the sequentialness that you just talked about as well? Like it's not just this sentence comes before this sentence, but it's also
and so when it's exactly. So when it's processing, even like your chat, that's given as context for the next message, right? So the chat history is context for the next message, and it's able to form those same kind of context and relationships between things in your chat history as well, and then use that against what's the knowledge that's already embedded in the model. If you notice though, and I've ran into this a lot, is if you start to try to get the model to generate really large amounts of text, eventually it'll get cut off because you run up against the model's context limit, which is something like 4,000 something tokens, I think, or maybe a little less than that. But they just recently added in ChatGPT, I noticed they added the keep generating button, which sort of, I guess, reinitializes it with your text and kind of sets a new context. But it'll kind of forget stuff, which is interesting if your chat goes on too long. And aside from that, I've seen some cool techniques of doing what's called like prompt compression, where you could take like the chat history, feed it to another large language model, and have it summarize that to reduce it to a smaller amount of tokens, then feed that back to the main large language model, so that it essentially still has a memory of everything you've talked about, but it's just condensed.
So it's like a cheat sheet of what happened before.
yeah, exactly. Yeah, that's a good way to think of it, I think. But yeah, that's sequential data, but it's not just text, right? It's it could be any kind of sequential data, like images, right? We've seen a lot of stuff with like AI generated art, right? Transformers are used in a lot of those models as well. and it's treating that like sequentially. It's essentially like, well, we've serialized this data into some numerical format, right? Typically called a vector. And it's like, I know the context of everything that came before. Well, so what should come next, right? It could be, and video as well. And one of the really powerful things about the transformer architecture is that these models can be trained really effectively without the need to label data sets. So back when I was doing machine learning related research in college, transformers were, I think had probably just came out because the paper was published in 2017. So it wasn't even something that like I was aware of at the time. But it's a lot of work in kind of traditional machine learning to label all of this data, right? You need a lot of experts. You need a lot of time. You have to go through the data. You've got to label it, and you got to do supervised training. And it's a pretty labor-intensive process. But the transformer architecture of neural networks are really good at making these connections and embedding that knowledge into the model without that supervised training. So there's no need to really label the data. You still need to ensure that it's quality data. Otherwise, your model's outputs will probably be, kind of crappy. But
yeah.
So that's
okay.
How
So
put up kind of view of what these models are.
So just to give us an idea of like when you're saying training for one of these, like how much data do you need before you like in order to get a level of quality out of it? Like,
so that's a pretty complicated question. And I don't, so when we say large language model, there's not like a specific definition for it, but kind of the working definition of large language model is a neural network that has hundreds of millions or billions of parameters. And the parameters are essentially what the model has learned. It's those connections between the layers in the neural network. It depends on the richness of the data. Like I've noticed playing around with building my own sort of model from scratch and training it on a specific programming language. It seems like coding languages generate more possible parameters with a smaller data set than like freeform text. Or maybe I got that backwards. I think I got that backwards. I think it's natural language generates a lot more parameters from a smaller data set than something structured like code. So I ran on maybe 100 and something megabytes of GD script, which is a scripting language for the Godot game engine. And I think it was something like that ended up resulting in probably like 200 million parameters in my model. And there's this relationship with parameters to size on disk as well, which is interesting. It's not one-to-one, but generally the more parameters a model has, the more generalized the knowledge embedded in it is. And so the more kind of complex the connections between information it has are. So typically models that are bigger are better at doing things and being smart and intelligent.
Or at least better at doing a variety of different things.
Right? But there's a huge compute cost with that. The bigger that it gets, the more RAM you need, GPU RAM you need to be able to run the model, to be able to train it and things like that. So it just depends, I guess. It's a hard thing to answer because it's a complicated problem, and it does highlight a problem that's been plaguing machine learning and AI research for a long time, which is understandability, right? It's not often clear how your data is going to map to certain relationships in your model, right? It's not necessarily that easy to determine things ahead of time, like how much compute you're going to need. And that sort of at this point has kept large language models the thing of like companies that have a ton of money to spend on, a cluster of 100 A100 GPUs.
So they can train it.
So they can train it really fast.
Yeah. Now I guess you could train, like you've done it. So you could train your own if it's, so it sounds like what you're saying is if you're training your own, then if you're aiming for something that's more specialized and less general, that's more likely to work for you than if you're trying to like have like replicate GPT-4, for example, which is a huge model.
Right. And so with that, that's a good question, because with that, there's two kind of approaches. You could train a smaller kind of foundational model from scratch, which could still be pretty expensive. Or you could fine tune an existing model. And you can do that with OpenAI's API. They allow you to fine tune some of their models. Fine tuning effectively works the same way as training the model from scratch, but your code just resumes from a checkpoint or a pre-existing model. And there's a couple different techniques, but the short of it is you're taking new data and you're using that to create these new layers in between the layers of the network that they essentially skew or bias the weights towards your new data, right? And so fine tuning allows you to take a big model that has a lot of general knowledge, and you still get the benefits of having all of that, but you can kind of guide it to be more specific. And so that's what I've done on the side. I'm building a game design assistant, by the way. And so I've taken a base model that is a relatively small large language model. It's still pretty big. That's trained on Java, Python, and JavaScript, so that it is a good understanding of coding embedded into it.
Right.
And then I've fine-tuned it further on a bunch of samples of the specific GD script language that I want to, train it on. I've curated that data, trained it, so now it can generate pretty complex GD script for me. And then I took it, and because this is getting a little in the weeds, but the particular model architecture that I leveraged as my base model is also capable of doing natural language really well, not just code. So I took an open source data set called the Open Assistant data set, and I fine-tuned it on that. And it's just a bunch of like chat-like interactions, right? So I started to fine-tune it on that. And what I ended up creating was a chat bot that I can ask with, hey, write me a script in, a GD script program that allows, a 2D platformer character to jump and move left and right. And it'll generate that. And it's mostly correct. I still have a lot of work to do.
It's getting there, I guess. Yeah.
It's getting there. Yeah.
All right.
But that's all kind of this background knowledge of, okay, so here's how these things sort of generally work. And that's a different domain than security, right? But that same idea extends very well into the realm of security. One of the things we do a lot in information security is generate a lot of data, right? I was just thinking about this recently as a pen tester. One of the hardest things for me to do is manage a lot of all the information I'm getting, I'm generating, right? Is managing that and trying to summarize it in my head essentially so that I can ask useful questions about it, right?
You have all of your, various different scans, tools you've run, logs from like Burp and all that, which
from the offensive side, but then even this applies to the defensive side too. Especially you've got lots of log generation. So naturally it makes perfect sense to me that, you could take these models and start using them for these sort of security purposes. And so we'll jump over. I already explained what a LLM is, right? Oh, that's weird. All right. Really quick before we kind of go further on, some examples of some large language models, some of which you may not have heard of and some of which you may have heard of. There's MTP-7B, which the 7B stands for 7 billion, because that model has approximately 7 billion parameters. It is an open source, commercially viable model that you can use it for commercial applications. It's open source. The code to train it is open source, and the data set it used is open source. It was developed by a company called Mosaic, and honestly, it's a great marketing stunt for them, because what they offer is they basically offer like private VPC based large language model hosting, right? So like, and this is kind of important to thinking about security, because we're going to, in some of our examples, we're going to, like Alex has a pretty cool demo where he's going to leverage OpenAI's APIs. But, you know, there could be some concerns with security of, you know, shipping data off to like OpenAI's servers, right? You know, so it's
not
nice.
Only that, I was going to mention as well, you were talking about the open, or the data that it was sourced from and built on, is important as well.
Yeah.
Because that can affect how it detects anomalies. So say a bad actor goes and tries to do like some weird supply chain attack to get themselves excluded from potentially a security data set, then that would be important. It's almost like a supply chain attack for an AI model.
Yeah, that's an excellent point. So there are definitely supply chain attacks with these. And one of the big ones I think we're describing is model poisoning or data set poisoning. And yeah, I mean, we're definitely going to, I think, see more of that happen, especially as LLMs start to become more and more integrated into companies. I was just thinking about this recently. I've been seeing a lot of articles that are like how to create a Q&A bot on your company's documentation, right? And it's like, okay, here's how we took a large language model and we fed it all of our company's documentation and made an internal web app so we could just go ask, like, you know, natural language questions and get the answers back about our company. That's really cool. But now that's another pretty juicy target for, you know, a malicious actor like an APT or something like that, right? And it presents its kind of own, new set. I wouldn't say new, presents its own security challenges, right? And risks. I think the fundamentals are still the same, right? But the devil's in the details.
Whenever you have a password reset question, call this number in Russia.
Yeah, exactly. Like you poison the data set to like have the model. That's a really cool idea. Like you somehow poison the data to you know, have the model always respond with some out of band, you know, phone number or email or website that's, you know, hosted by a malicious actor. And it depends on where the data is sourced from. It's another big problem I mentioned earlier is like the observability. With these models, they're so big and complex that it's still an ongoing area of research of how to just like understand the connections that they have. How could we assess a large language model for vulnerabilities? Like, has it been poisoned or backdoored, right? How could you sit there and like try to determine that? And there's actually some tools that try to do that and there's some methodology out there, but I haven't really delved into that myself yet. It's on the roadmap.
Well, another thing for that specifically is that it's also a business's reputation. So if it can get a model to say profane things about the prompt that you're giving someone, then it looks bad on the business that they allow that. It's also important to sanitize the input to prevent those kinds of attacks.
Yeah. But then that's what's really difficult too, is like the data sets often are really vast as well. So it's a very big challenge to try to produce these kind of models in a way in which you kind of can control everything about it. So I'm interested to see like what kind of techniques spring up around things like protecting AI supply chains, you know, scrutinizing data sets, scrutinizing the models and things like that.
It sounds like you almost need like a QA model that checks the input into your other models.
Actually, did you just come up with that? Did you just think of that?
Yeah.
Because that's the thing. That's the thing.
It isn't.
Yeah, people have been training models on, and so so one of the things to do to try to like prevent against things like prompt injection or, malicious data being, a part of the training set is what's called adversarial training, where there's a couple of ways to do it, but you can have a model that tries to detect and classify things as adversarial. Okay. Or you can also fine tune a model using negative reinforcement techniques to try to reject things that are adversarial and drop out. You can also do dropout techniques where you essentially remove weights from the model that tie to outputs that you don't want it generating.
Is that basically what they do for, like, is that what they do for their guardrails?
Yeah, something like that. That uses, so like, I don't know exactly how OpenAI is doing it, but one of the main, I think, so the main algorithm / technique for kind of creating those guardrails and tuning models for human preference to be like human friendly is using RLHF, which is reinforcement learning human feedback, or it's reinforcement learning with human feedback. Oh. So you're fine tuning, but you essentially have a reward system that's tied to like if you've been using ChatGPT and you ask it to regenerate a response, and then you get a little pop-up that says, was this better, thumbs up, or was it not? Yeah. That's what you're doing. You're training their model, and you're doing that reinforcement learning with human feedback. You're providing the human feedback of this was better, right? And so it's going through, and I don't know what their process is because there's like so many different ways.
I usually run into that prompt when there was an error on their side, and so it like disconnected or something like that. And it's like, yeah, this was better because the last time you didn't give me an answer.
Yeah,
Anyway,
so yeah, that is a way to kind of curate things and do that. There was another algorithm that was just published that I can't remember the name of, but I have the paper somewhere because it's what I think I'm going to use for my model to try to make it more human friendly. It doesn't require that human interaction though. It's you can generate, I think it's kind of the gist is you can generate a data set that is already like the data set itself is already like the human preferences, right? And kind of tune on that. But yeah, interesting stuff. There's so much like here that's going to, spring up in the next few years or later this year, even, right? As this technology keeps getting used more and more. Yeah. So MTP-7B, open source model. It's pretty good. There's a couple versions of it that you can play with, like MTP-7B Chat. GPT-2, that one probably you've heard a lot. That's a specific model, and that's one of OpenAI's models that they have released. It's not necessarily open source, but you can use the base model, right? But like their code that they use to create it and their data set and stuff is not really open source. And there's some I have some ethical issues with that personally because for example, my business model is probably bad because my source code for training my model is open source. My data set is going to be open source, right? Like, so, somebody could in theory duplicate that pretty easily. But as we've seen, actually, people have been able to duplicate ChatGPT by getting ChatGPT to generate data that is similar to what ChatGPT was trained on. So, sure. You can kind of get these models to leak themselves. Claude is another interesting one that I haven't gotten to play with, and it is by a company called Anthropic.
Yeah, I've heard of that.
Yeah, what's interesting about that one is it has a massive context. It's like something like 10,000 or 100,000 character or tokens. So I'm waiting to see if I get access to that. ChatGPT, I'm sure we all know that one. Dolly.
A small note for the ChatGPT specifically is that you can actually change the model that it's using on the back end if you're in the Pro edition, I think, right?
Yeah, if you have the Pro, you can switch between their 3.5 turbo model or their GPT-4 model. And that's sort of the foundational model because that's an interesting note. The reason why ChatGPT is called ChatGPT is because it's a version of these base models that are tuned to be human friendly and understand how to chat. You couldn't go and take like MTP7B, for example. You can't just load that model up and chat with it. It hasn't been fine-tuned to have those kind of interactions, right? So basically these foundational models are like super fancy autocomplete, for text and text with LLMs. But DALL-E, not to be confused with DALL-E, which was the art generation model. DALL-E is another open source commercially viable model that was built by Databricks. So just another one that's out there.
The other thing that this slide is going to start to cover a little bit, but that there's a whole community around the LLMs and like interacting with automation by feeding it feeding it a question to do something, and then it handles the automated response, and you can try and have automated scripts happen from that response. There's also, I think Jason had talked about that he had started playing with some plugins that you can use for ChatGPT, depending on if you're like a beta or something like that. And so you can have this whole community around the actual LLMs by leveraging what they're good for.
Yeah.
So,
yep. Yeah. So I think what you're hinting at is like AutoGPT, for example, right? And somebody just mentioned it in the chat. Yeah. So I'll get to that in a second because I have a lot that I can say about AutoGPT. But so the things that LLMs are really good for are things like translation. So the transformer architecture of model was actually invented to do language translation. It wasn't invented for these kind of models we're seeing now. It was invented to be effectively a much better way of translating between, like, if you want to translate French to English or Japanese to Russian, right? But it turned out that architecture was extremely good for just working with natural language in general. And then to me, it makes perfect sense that if we're able to take and statistically model natural language, well, we communicate all of our information, all of our knowledge, right, through natural language. So if we're able to model that in a computer program effectively, right, it makes sense to me that it would be as powerful as it is, right? It's like this, fancy database of all of human knowledge in a way, if you want to think. That's how I just think of it, right? It's like, I think, but building one kind of from scratch, like, to me, the models are kind of dumb. So, I think a lot of the like, oh, this is like sentient and stuff, that's all just smoke and mirrors. Like,
yeah, it seems like it is, but it really
it's an illusion. Yeah, you're being tricked. Exactly. LLMs are really good for text summarization as well. So taking lots of text and being able to summarize it down to like salient points. And then question answering is another one, right? Being able to ask questions about text and documents and get answers.
I've taken like legal jargon and plugged that in and said, explain this to me in English.
That's a good one. Explain it to me in English. Yeah. Instead of what, like lawyerese or something like.
Yeah. And the thing is, I think you've touched on this a couple of times, but I think one of the really important takeaways that we must never forget at this point is that although some of these languages have gotten really good and they are often correct, they can reply with stuff that's factually incorrect, and so you really have to be cautious about that, and like don't use it for that mission critical thing that you're expecting that the answer is going to be right every time. I mean, I've actually taken data that and thrown it in using the APIs to a model and basically tuned it down to be like so that there's almost zero creativity in it.
Yeah.
I've gotten different answers each time I ran the API. It's like, how's this possible?
Yeah. You did like the temperature value, right?
Yeah, exactly. Tune that way down, and it's like it's still not always the same. Yeah.
You can get almost deterministic results, but not quite, because
and so you gotta be really careful about that though, how and where you're using it because of that.
Yeah.
And we'll actually be able to see that in the demo a little bit, to how it'll misclassify something based on the model you're using and other things like that.
Yeah, that also highlights the point that that's what these things are. They're statistical models. So inherently they are somewhat random, right?
Yeah.
And I mean, you brought up the legal jargon. There was that thing recently where some lawyers used ChatGPT to like gather a bunch of sources, and the sources were just not, they did not exist. Like it just
They were
made
fabricated. Well, and the end excuse from the attorney, I believe, was something along the lines of, "I thought it was a search engine."
Oh, okay, yeah. Well, that doesn't make you look any better, buddy. You know.
I think if I remember correctly, that's called hallucinating or hallucinations, right? Whenever it gets something wrong or makes something up.
It just like makes something up.
Coin, yeah.
Yeah, I think so. I think that's it. Yeah. So it's definitely important to be wary, and you know, you always need to have that human validation of whatever these models spit out. Don't trust them. You know.
No, they're still very useful, but you just have to be, yeah. Don't
very useful tools, but at the end of the day, it's a tool, right? Tools are tools. So it's kind of how I look at it. They're just very useful tools. And then, of course, text generation, right? You can have these models generate new text from a prompt, or because that's essentially what they do, right? Is they're given some context and they use the embedded knowledge to basically guess what comes next. And that's how every interaction actually works with LLMs, which is kind of crazy that what seems like such a simple mechanism in a way gives rise to such complex results. I find that to be really awesome. So that's a lot of, you know, yakking about things that have not been related to security at all, right?
It's good foundational stuff, though. So let's talk about security.
Let's talk about security a little bit, and maybe we can talk about AutoGPT at the end or something, if we got a little bit of time. So how can we leverage LLMs in security? So a couple of ideas I had is summarizing log data, right? Trying to see, okay, what are the salient points, or what, you know, what kind of basically just helping you gain that high level picture more quickly, right? Answering questions about volumes of security data. So again, the logs, or an idea I had recently was, could I feed a large language model like a Nessus scan, and then start asking it questions about those results, right? Like, were there any, you know, how many criticals were there? Of course, you can see that stuff in the dashboard, right? But you know, kind of building up from that idea of being able to ask questions about your data directly, without having to go through that arduous process of like, well, I have gigs of data or whatever, and I need to like build that mental model of it all in my head. That just takes a long time. And I don't think humans are like so great at that. We're good at having ideas, not necessarily storing them, I feel like. At least I'm not. You could, for example, use LLMs to identify and classify emails as like phishing emails, right? Still to this day, right? Like phishing is a massive, a huge, is a very viable way for threat actors to get into networks. That's what I was trying to say. And it's a hard problem, right? Because it's one of those fuzzy things, right? So LLMs are good at fuzzy things, right? You know, using that to at least flag emails, right? And then maybe render them inert or pull out links or things like that, right? Could be very powerful. And then another one, which is kind of gets at the source of a lot of security vulnerabilities, right? Bad coding, right? Insecure coding. So we can leverage large language models, which that can generate and understand code, to assist in secure coding, right? There's risks that come with that too, though. Like, for example, again, these models are trained on other people's code, and lots of people like to write insecure code. So, right, there's, you know, potential for that model to generate insecure code. And then a lot more. I mean, I don't know. Do you guys have any ideas off the top of your head? No?
I know that specifically with essentially event correlation, this was even before the bigger boon of actual like LLMs and AI stuff, but using IDSs to help correlate information over the network can help make anomalies from the traffic more identifiable for the security individual. And so if there's some weird traffic that Barry from accounting is talking to your jump server to get into the secure network, then that's probably a little suspicious. And so if it's an abnormal habit, you can see this also more with AVs and other things like that. It can help flag that information and then also leverage it or notify the individuals about it.
And I was thinking another area that could potentially be leveraged or leverage LLMs would be tasks, and this isn't exactly security specifically, but it's closely related, which would be like audit type functions. So like risk analysis, that sort of thing. And I'm thinking back to, when I was working in corporate America, and there was a lot of effort that went on to even determining like which of our thousands of internal applications should be prioritized first for penetration testing or scanning or whatever. And so we would be going around asking people for various types of input in order to be able to try to put some risk analysis around that. But that sort of thing, when you have like lots of data about lots of things like that, and you're trying to figure out, okay, well, which one should we prioritize first? That's a question I think that an LLM should be able to answer at least as well as the average person. It may not be the perfect answer, but it's going to be a reasonably high quality answer, you would think, right?
Yeah, that's a really good idea. And comes back to the idea of using these to essentially summarize data and be able to ask questions about it.
Yeah. What are my top 10 risks based on all of this information I have?
Exactly. Like what are my top 10, highest risk servers or assets? And okay, now I see those. Well, what OS are they running and things like that, right?
Oh, and actually, sorry to interrupt, but I was actually thinking. So here's the thing that they can do that a typical vulnerability scanner is terrible at, and that's understanding the business context.
That
are there. Like this server is unpatched, and so it's a critical. And it just leaves it at that, and you're like, okay. But you don't know what that server does or how it's tied to the business or how critical it is. And
is it isolated on its own subnet, right? Like,
but with that extra context data, your GPT or your LLM will be able to make a better decision on that, I think.
Yeah. That's a really good point. And like, I'm excited to be able to see kind of like more of these tools to, come about, because again, it's pen testing. Like I get very fatigued sometimes of just like, I've got a pile of information. And also I'm always thinking of ways, well, how can I like pen test more, how can I hack more things? I'm only one person. And to me, I think the future is kind of being able to intelligently drive AI models to assist with, pen testing. Yeah, that's a really good point, right? An LLM for OSINT, that would be really awesome, right? Feeding in, your recon data and whatnot from, external scans and blog posts and things like that, to be able to ask, okay, so what tech stack does, this target company's main web application seem to be using, right? And how many instances of Angular-based apps, or all this stuff, right? That you can start to ask.
It's a lot of the same things that we can figure them out ourselves, but if we're looking at a large number of applications simultaneously, a model can help with that. Hey, I don't want to shortcut things too much, but we're running down to the last 15 minutes. I want to make sure we have time for whatever demos you have. So
I think Alex should go with his demo first, and then if we have time, we'll go with my demo because mine's not as exciting. Alex wrote a bunch of code for his. I just installed a plugin into VS Code.
Oh, okay, yeah, that's I could see that then. All right, so Alex, what do you got for us?
I mean, that's still an interesting demo as well.
You're just being nice. Go ahead.
All right, so all right, can you see my screen?
Yes.
Cool. So, long story short, this script takes a bunch of emails that were compiled from Spam Assassin that were open and publicly accessible. And it goes through and takes however many specified emails you want and sends that to not ChatGPT. It uses OpenAI's APIs to query GPT to determine if it's either spam or not spam. And so I'm actually going to turn my video off so that way hopefully it helps with a little bit of bandwidth. These are kind of like higher level numbers for different things like rate limits. The tokens that Cory was talking about is how it breaks down the text into identifiable strings. And then you are limited based on the amount of tokens that you use. So all of that.
Real quick note on the tokens thing, by the way. With OpenAI, they define a token as roughly 4 standard English characters, but that could vary based on the type of tokenizer that's used. So, but whatever they've got behind the scenes, which
they actually have and I don't remember the name off the top of my head, but I know that they have a tool that you can leverage to get a token count before you spend stuff. So that way you can kind of figure out your costs ahead of time. Exactly,
which is really cool. Anyways, sorry, Alex.
Yeah, no, that's good points. And probably something in the future that I could implement with this script because it doesn't do that check. So this particular email kept giving issues to ChatGPT's 3.5, but 4, it was actually better at classifying that it was spam. And you can tell that it was in the spam folder. So that's how Spam Assassin qualified it. So if I do this, it'll say it's reading from that and enter to send. So the actual email is from this user. Its recipient, like 2, was this individual. And it was the only body of the actual text from the email was this string of characters. And so it says this does not appear to be a valid email. And so this is 3.5's response to the actual classification of this email. So just to show you the difference of what a quality model will do,
hopefully
in this one, it qualifies as spam.
Spam.
Yeah. So that shows you how important it is to make sure that you're leveraging a very finely tuned model for whatever task you're doing. If you can fine tune it. If you can't fine tune it, you have to add more parameters to help give it more context for things. So that was one particular email that I kept running into issues with its classification. So now, instead of that, we're just going to do text C, which quick help shows you that C is count. So how many emails it'll send. So we're going to do text C, and since this is GPT-4 and it's a bit more expensive and doesn't allow you to send as many tokens, we're only going to do 10. And so the email type is ham, which means that it's not spam. That's been the the qualification that I've seen from Spam Assassin's data set is funny. That ham is not spam and then it's spam. So 4.0 actually qualified all of those as ham, which is not spam. So I'm not showing the exact responses. We can show the responses by doing something like this, and it'll show you the whole email, and I'll show you a response at the end. So There we go. So it fell under spam, and it has qualified them all as spam. So that was underneath the classify result function. And this was the actual body of the email.
Yeah.
And it's talking about, are you in debt? So yes, it was spam. So now if we go back to keep doing that and do this, using 3.5, we can see with a lot more results. I think it was 100 that I did before. We might end up running into a rate limit, but it'll process all 100 of the emails and give you the summary of it at the end.
Yeah. So 3.5 turbo is a lot faster than 4.
That's also, as I mentioned, is 4, while it is a lot more fine-tuned, or it has more parameters, not fine-tuned, it takes longer to respond than 3.5.
An interesting thing too, though, is you can OpenAI makes 3.5 available for fine tuning, so you can actually fine tune a version of their 3.5 model on your own data sets. It gets a little expensive though, because you pay for the fine tuning API costs. And you also pay a higher price than for API calls to your fine tune model, and it's something like $0.012 per API call, which is per token, which is pretty high actually compared to other.
Per token, yeah.
So,
wow.
Or no, sorry, per 1,000 tokens. Still,
okay.
It's a lot more expensive than
holy crap.
Their other models, yeah.
But yeah, so even though the 3.5 model had a larger corpus of information to iterate through, it's still, even though all of it was spam, qualified some as ham and some as unknown. So that just kind of shows you what having a more parametered or a finely tuned model will get you, is that it can't qualify as best as something that has less parameters. There's one that was.
But the other thing to point out here too, though, I think is that you're using GPT 3.5 Turbo, which hasn't been fine-tuned for recognizing spam.
Yeah,
right.
That is,
it's a general model, so you could,
exactly,
in theory, you could train it to be better.
Exactly.
Yeah. And that's what I was saying. It's either fine-tune or more parameters to help with classification.
Gotcha. And fine tuning is a pretty powerful approach for getting these general models to perform a lot better for very specific tasks. And you don't generally, a thing I didn't mention earlier, but with fine tuning, you don't need as much data as you would for training a base model. A lot of these model architectures are really good at learning quite a lot from even pretty small data sets when you fine tune. So you generally don't need as much, which is pretty cool.
I think you just hit a rate limit.
Yeah, it's either that or it's having network latency issues. But yeah, that's essentially the demo though. Just showing how leveraging different types of models with different parameter amounts can give you different varying qualities of being able to determine that.
Very cool.
There we go.
Yeah.
So I did hit a rate limit, but that one, it was ham, and
still thought one of them was spam.
Yeah, one of them was spam, and 2 of them were unknown.
Yep.
So
cool.
Yeah, with this kind of thing too, you wouldn't, and that brings up the point of these models can get things wrong, and so with something like this, it would be good to key that into alerts or quarantine the email, right? For just flag it for review, right? But you wouldn't want to take some destructive action or, concrete action, I think, off of these kind of results. In cases like that.
Not until you have a much more proven model.
Yeah. If you fine tuned it and you're able to get, when you do your evaluations of the results, if you're able to get really high, you know, accuracy and things like that. This is getting into the weeds of like the data science-y stuff now.
Yeah.
But you know, if you have a statistically large enough and statistically significant, you know, set of evaluation results, then you could probably start to trust the model more. So I have a pretty quick demo. I just wanted to show. We talked about like secure coding, right? So AWS actually has a product that they've come out with called Code Whisperer, which is AI code generation. It's like it acts a lot like Copilot, like GitHub's Copilot. And
you have to be specific now with that.
Yeah.
Not Microsoft's Copilot, yeah.
Right, not the security Copilot, the GitHub Copilot, which is technically still Microsoft.
It's still, yeah, that makes it even worse.
Yeah. Yeah, so it just, you know, they've got this fancy looking page here. It does things like allows you, you know, can generate code from you based on comments, you know, help you kind of understand what code is doing, flagging things, but also it has the ability to do security scanning.
Yeah.
And so I've got a little example set up here. I just cloned this project called DSVPWA, which is damn simple, vulnerable Python web application, I think.
Oh, okay. So based off of DVWA or something?
Yeah, kind of in that same vein, right? So it's just got a bunch of vulnerabilities, but it's a, you know, a little web application. And so the way that Code Whisperer integrates with VS Code, for example, which right now they only support, I think they support like IDEA, like IntelliJ and stuff like that, and VS Code, is you install the AWS toolkit, and then you get this developer tool, Code Whisperer.
Are you sharing your screen?
Is it not showing? I am sharing.
I'm just seeing the browser still.
Yeah, I see the browser.
Did it share the window only? Sorry. Let me try again.
I just wanted to check and make sure.
Yeah.
I didn't know if it was my connection lagging or...
Here we go. No, I goofed and shared a window instead of a screen, and I thought I shared my whole display.
Okay, cool.
That works. We can see it now.
Yeah. Okay, so I've got this little, you know, vulnerable project here, this Python web application. It's got a bunch of deliberate vulnerabilities built into it. And what you do is you install the AWS toolkit, and you sign in, and you can do like a personal account that has like a free trial, essentially, or a free amount that you can use it for. I don't think it expires. It's called like a AWS builder account, which is just what I set up. And under the developer tools, you have Code Whisperer, and you've got this nice little run security scan button here. So
that's convenient.
Yeah. So what you do is you have to have a file open. But what it'll do is it'll scan this file and its dependencies. So it'll go and grab the things that it imports and scan them as well. And so if I run that, it'll, you know, scanning this file and its dependencies, and it'll just take a little bit of time.
Oh, so normally, I guess you'll probably just try to target whatever your entry point is.
Yeah, exactly.
That should pull the rest. I wonder, is it recursive too?
I honestly don't know, but it seems like it is because I ran this beforehand to make sure. But you get quite a few results here. Right?
I saw the announcement on it. I haven't had a chance to play with it myself yet. So yeah.
So what's nice is you get, you know, these problems here. Like for example, this we've got the CWE 77, 78, and 88
command injection
OS command injection. If you click that, it takes you to the line, right, in the file that it flagged as being vulnerable, right? So you can go and investigate this, and you know, then you know, if you're developing the app, you can say, well, okay, let me spin this local version of the app up and test it, right?
Yeah.
Resource leak. Some interesting thing here: allocated resources are not released properly, so it's kind of saying like maybe this could be a, you know, resource exhaustion flaw. Hard-coded credentials, so it's, you know, hard code checking a password here, right, and a username. Was there anything? Let's see if there's anything else interesting here. Yeah, one thing I noticed it doesn't do. that would be nice to see it do at some point is it doesn't. I don't think I can see it. It doesn't give much more information other than kind of highlighting it.
Yeah. So it still leaves it up to you to figure out why is this an issue. So maybe that'll be an improvement for the future. I am seeing in other places like the dark web monitoring that we have, for example, where you can actually push a result set to an AI to interpret for you and give you some more
that's really
context around it, right? Which is
that's really cool. I would like to see, and maybe I'll have to build it myself. Who knows? I would like to see like this kind of scanning also tie in with things that do like dynamic analysis, like code QL. I would like to see a model that finds these vulnerabilities and then generates code QL, right? Code to test for that, to like identify it or something dynamically to see, okay, can this actually be exploited or something like that?
Yeah, that would be cool.
That would be pretty cool. LangChain is the framework to use that makes a lot of that kind of stuff easy. Just like chaining different models and stuff together. It's pretty cool.
Yeah, and one thing that I was going to mention really quick that we kind of brushed over, but coding assistance is really powerful with like these different types of models, so Code Whisperer, or
I wish we can just do that.
GitHub's coding Copilot. So it really helps essentially become like a super powered IntelliSense, and allows you to like complete your code faster. So it's something that as security professionals, if you're writing tooling, then that's really powerful for you because it can make you get your job done faster.
I wonder if this will work. Write a function to classify an email as spam or ham. All right, I don't actually know how to get it to. I haven't messed with Code Whisperer's like plugin enough to know how to get it to like
start writing code. Yeah, I know how to do Copilot, but there we go. It's started. That took a lot longer than it should have.
Yeah, that was not very fast.
All right. Yeah. Well, how about we save that one for another time? We are at the top of the hour, so we need to wrap up.
Yep.
But I think this was really good. Do you guys have any parting thoughts? Cory first.
I just want to say thanks for your time. I hope you learned something, and I don't have anything else to add except for be on the lookout for more AI related content from us, because I'm cooking up some stuff related to
so am I
hacking those. And Jason's cooking up some stuff too. So just be on the lookout. We'll have more. This is all really like super interesting stuff, and in my opinion,
we're kind of excited about it. We're just nerding out over it.
We're definitely nerds, but I mean, this is, it's powerful technology, and it's not gonna. We've opened the box. The Pandora's box is open. This stuff's not gonna go away.
Yeah, it's not going away. So we might as well figure it out. I mean, that's what we do, right? That's what makes a good security consultant, is somebody who figures the stuff out, and because we understand it, that's how we can figure out how to break it. So
exactly.
Alex, anything?
Yeah, I just say explore with these types of tools as much as you can. See where you can try and integrate it. Maybe it's something unconventional that we hadn't thought about. And if you have anything that you find interesting, tweet it at us or message us or email us, however you want to get
or join the. That's a good point. Professionally Evil Slack. I added a Pew, because this is what we're calling the webcast now. Professional Evil Webcast. Pew. Pew pew pew. So
we really like acronyms here, don't we?
Yeah, I know. We actually came up with the acronym first.
Yeah.
In this case, I don't think that's true, but we usually do. But yeah, so that's in there. So if you have other things you want to bring up on this topic, feel free to drop it in there, and we'll be in there watching too. So and yes, the future webcasts, Jeannie just put the link in there for us. So as we plan on doing webcasts like this about twice a month, of some type of webcast about twice a month. So you should be seeing a lot more from us in the near future. So thank you very much, everybody.
You get to see my mug some more. Thanks, everybody. Have a great day.